Hello mathematicians, thank you for joining me again today. And we're going to look at the limit as x goes to 0 of 1 over x plus 2 minus 1/2 all over x. So as with any limit, we're going to start off and we're just going to plug 0 into the function to see what happens. We know that if we get a number out, this would be continuous at the point, therefore we would have the answer. Now, what's going to end up happening here is if I plug in 0, I get 1 over 0 plus 2 is 2 minus 1/2 all over 0. Well, 1/2 minus 1/2 is 0. Divided by 0 is 0 divided by 0. Well, we know we can't divide by 0, so this is undefined. So my function is not defined at a point, it'll be discontinuous. So I can't just find the limit by plugging 0 in and being done. However, what I do end up with is the indeterminate form 0 over 0, which means that I don't know what the limit's going to be. And in fact, in order to do that, I'm going to have to do more work. And so in order to do more work, I'm going to have to find some way to simplify this. If we had had a rational function, we knew that we could factor top and bottom and cancel things out. But here we don't have a rational function because we have a fraction minus a fraction over a fraction. So instead what we're going to do is we're going to simplify the fractions by using a common denominator to combine these into one fraction. Once we do that, we'll be able to use more simplification techniques in order to finish this. But the first trick is I have to combine these. So now remember, to add fractions, I have to find a common denominator. So the way I'm going to do that here is I'm going to multiply both of these fractions by the other's denominator. So that is, I'm going to take 2 over 2 times 1 over x plus 2, and then I'm going to subtract 1/2 times 2 plus x over 2 plus x. Now in that way, what I'm going to end up with is both of these are going to have the denominator of 2 times 2 plus x, and so I am going to be able to combine them. And so what I get here is, on this one the top is 2. Now notice I have a negative, so I have to subtract the whole top of the second one. So the top over here is 2 plus x. So I get 2 minus 2 plus x all over 2 times 2 plus x. And now I'm going to want to simplify that because that'll help me as I go. But I get 2 minus 2 is 0. The negative times the x becomes negative x on top all over 2 times 2 plus x. So now that I've simplified the top, I can bring that back and plug that in up here and then continue to simplify. Alright, I pulled my simplified version of the top and I plugged it in up here. And so what we notice now is that we have a fraction divided by a fraction, so we should continue to simplify. In order to divide fractions, we multiply by the reciprocal. So I'm going to get the limit as x goes to 0 of negative x over 2 times 2 plus x times 1 over x. Now in this case what I get is I actually do have a rational function now, so I could go back to my last technique of factoring top and factoring bottom. However, the nice thing about this is that actually I've already factored the top and bottom, so I can determine what needs to get canceled. So what I have here is I do have an x over an x, because I have an x on top and bottom. And because I'm looking at the limit as x gets close to 0, again, I don't care what happens exactly at 0. So therefore x divided by x will be 1 as long as x is not equal to 0. So we can simplify this limit to the limit as x goes to 0 of negative 1 over 2 times 2 plus x. Now because I was able to cancel these out, I'm left with the new limit. And so in order to calculate that new limit, I start all over again and I say, okay, well let's plug in 0 and see what happens. If I plug in 0, I get negative 1 on top. 2 times 2 plus 0 is just 4. So negative 1/4 is a number, which tells me that my function is continuous at the point 0. So if I want to find the limit, I just plug in 0, and so the limit is just going to be negative 1/4. As such, we found that the limit as x goes to 0 of 1 over x plus 2 minus 1/2 all over x is equal to negative 1/4. And again, just to reiterate, what we ended up here was we had two fractions being either added or subtracted. And our technique was we're going to combine those two fractions into one fraction by finding a common denominator. Once we do that, we're again going to simplify algebraically, and this will likely turn into a rational function so that we can use the techniques we used on rational functions to finish up this limit. Thank you for joining me today, mathematicians. I hope you enjoyed this, and I hope you learned something along the way. If you did, make sure to like the video and to subscribe to the channel down here. This will help make sure that other people get to find this video so that they can also get help on calculus.